Have you ever stopped to think about how your phone, your laptop, and your smart TV all, talk to each other? It's amazing, right? We're sending messages, streaming movies, sharing huge files in the blink of an eye. But behind all of that, there's this hidden language. It's a language that had to be invented from scratch, just so our digital world could learn to communicate. So let's go ahead and decode that language together. Just think about your average day. You're using networks constantly, probably without even giving it a second thought. You're zipping off a quick note through an instant message.
Or maybe you're collaborating with your team on a shared document, or just looking something up on a wiki.
Then you're mindlessly scrolling through your feed on Facebook.
Or catching up on whatever's happening in the world. See? All of these things, the entire fabric of our modern lives, they are all built on one single fundamental technology. And that technology is, of course, the computer network. At its heart, it's just this incredible system, this invisible highway that carries everything from a simple text message to a 4K video stream. And it connects all these wildly different devices together. Okay, but that brings up a huge question, right? How in the world do you get billions of devices made by thousands of different companies, all running totally different software? How do you get them all to agree on the rules of the road? How do they all speak the same language? Well, the answer is something called protocols. You can think of protocols as the grammar for digital communication. Seriously, without them, it would just be complete and utter chaos. These are the agreed-upon rules that define everything. The timing, like when to speak and how long to wait, the acceptable size for a message, even how that message is encoded so another device can actually understand it. It is the universal rulebook for machines. And just like any human conversation, every single network communication, no matter how ridiculously complex it seems, can be broken down into three super simple fundamental building blocks. So first, you've got the message source. That's the sender, like your phone when it's sending an email. Second, there's the transmission channel. That's the pathway. Maybe it's your Wi-Fi network or an Ethernet cable. And third, you have the message destination, the receiver, like your friend's laptop. Sender, pathway, receiver. That's it. It's that simple every single time. But not all digital conversations are created equal. Sometimes you're just whispering a secret to one person, and other times you're basically shouting from the rooftops to a whole crowd. Networks actually have different ways of handling these different types of conversations. There are three main flavors to know. You've got unicast, which is your classic one-to-one message. Then there's broadcast, which is a one-to-all kind of announcement. And finally, multicast, which is a more targeted one-to-a-group message. Let's break down what that actually means. Okay, so first up is unicast. The best way to think about this is like sending a private, sealed letter. The source device sends out a packet of information that's addressed to one and only one specific destination. Yeah, other devices on the network might see it whiz by, but they know it's not for them, so they just ignore it. Then you have broadcast, and this is the complete opposite. This is like grabbing a megaphone in a crowded room and just yelling. The source sends out one message, and it's delivered to every single device on that local network. Everybody gets a copy, whether they wanted it or not. And finally, we get to multicast, which is this really clever middle ground. This is like a conference call or maybe a group chat. The source sends just one message, but it's only delivered to a specific group of devices that have basically raised their hand and said, hey, I'm interested in receiving this. It's way more efficient than sending a bunch of individual unicast messages, but it's also way more targeted than a broadcast. All right, so we know how devices speak, and we know who they can speak to, but there's one more piece to this puzzle. How do they manage the flow of the conversation so they're not all just talking over each other all the time? It all comes down to how the line is shared. The simplest mode is called Simplex. Think of it as a one-way street. A perfect example is a radio broadcast. Information only flows in one direction, from the station to your car. Then there's Half-duplex, which is exactly like a walkie-talkie. You can talk or you can listen, but you can't do both at the same time. Over. Finally, you've got Full-duplex, which is just like a normal phone call. It's a two-way street where everyone can talk and listen simultaneously. So let's do a super quick recap of the key takeaways here. Number one, for networks to work at all the devices need to agree on the rules, and we call those protocols. Number two, every single communication has three essential parts: a sender, a pathway, and a receiver. 3, messages can be sent one-to-one with unicast, one-to-all with broadcast, or one to a specific group with multicast. And finally, these conversations can be one-way, which is simplex, or two-way, which is duplex. So there you have it. These are the absolute fundamentals, the basic grammar of the network. But understanding them raises an even bigger, more interesting question. In a world with trillions of messages flying around the internet every single second, what happens when one of them gets lost, or gets corrupted, or just plain takes a wrong turn? How does the network fix itself? Well, that is when the real journey begins.